Hey guys, how you doing? This is Coach Scott. Again, we're on Purple Wave Chemistry, and what this is we're going to call it Unit 3 Review 1. Let's talk about these energy bar charts. And I know some people still don't totally have this yet, right? Um, and that's okay. Uh, what they are a very good way, they're a very good tool, if you would, to understand where the energy is either going into a system or out of a system. Okay. And again, very few rules with them. And again, let's see what we got here. So we got what? ETH, that's thermal energy. So that is energy that's causing a temperature change. You're either one increasing the velocity of the particles, the atoms, molecules, or what have you, or you're decreasing. Okay, and then that's going to lower the temperature. Phase energy, well, EPH, phase energy is the has to do with the attractions or the breaking of the attractions between molecules in a system. All right, so let's say I've got some really cool, of course, Dr. Pepper in here with some ice. And I set it down, even though it's a really cool Yeti mug. Okay, if I set it down there and I leave it overnight, all right, I've got, let's see, I've got ice and I've got soda in there. So let's talk about this first for the ice. So I've got solid ice in there. That's my system. All right, I've got solid ice. What happens if it sets for like 8 hours? So it starts as a solid. So that means the phase is 1 bar. And that's the only one that we're going to be really silly about is phase change. So that's 1 bar. It's ice. So it's at least 0 or a little below that. So I can now on the thermal energy, I can be a little subjective. I'm going to give it a half a bar. All right. You can give it a bar. You can give it 2 bars. I don't care. All right. The key thing on the thermal energy is on the next part. All right. What happens when it melts? All right. So it's going to melt. It's no longer solid ice. It's going to be a liquid. And remember that for phase energy, we use 2 bars for liquid. Just show me 2 bars there. That's all you got to do. Okay. It's not going to go to a gas. It's not going to boil, right? It's not going to evaporate. So it's not going to be 4 bars. If it's a liquid, it's going to be 2 bars. Now, when it sets, it's at room temperature, and even though it's a little cold right now, say it's 20 degrees C. So say it started at least 0 or -5 or whatever when it was solid ice. So it's going to melt until it's at least, what, 20 degrees C. So I'm going to give that 2 bars. Could I give it a bar and a half? I could. Could I give it 1 bar? That's okay, as long as there's more bars here than there. So let's think about it. So that's the part. I've got my thermal energy. I've addressed that. I've addressed my phase energy before and after the initial and final. Now let's see what we've got. I've got over here, I started with a bar and a half, 1.5 bars. Okay, I finished up with 4 bars. So that means what? That means some energy had to be added into the system from the surroundings, from the universe. So I've got to put an arrow in there, and I added what, 2.5 bars? I can do something like that just to let me know that I added some energy to make it to the final state. That's it. Now let's go to a boiling example, right? Let's use some gas. Let me go ahead and erase all this. Let's say I'm making some soup. Got some chicken noodle soup. I'm gonna heat it up. All right, so it's liquid, right? It's liquid. If you ever open a can of soup, it's going to be liquid. All right, so now that means the phase is going to be in 2 bars. 2 bars, just like that. And I'm gonna put soup. That's the system. Soup. Cool. Now I'm gonna boil it. Okay. So it's going to go up to 1, 2, 3, 4 bars. All right. It's going to start changing into a gas. So it's got 4 bars. Okay. My thermal part, my ETH, So it started at room temperature. So I'm going to give it 2 bars. All right. Cool. So now, let's see. It's starting to boil. Most of it's water. So that means what's the temperature? About 100 degrees C. So some of it's going to boil away. So I'm going to put it at, I don't know, 4 bars. It's hot. I could use 3 bars. It doesn't matter on thermal. Okay? So let's see. I've got 4 bars. I started with 4 bars. And let's see. Some of that was boiled away. So now I have 8 bars. So that means I had to add, 4 bars of energy into the system. It had to come from the surroundings. Okay? That's it. Now let's do a freezing one. Ooh. Let's do a freezing one. So I got some water. Let's say it starts at 40 degrees C. Okay. So it's going to be liquid. It's liquid. Okay. It's liquid water. It's 40 degrees C. Man, it's a little hotter than 20. So let's give it, 2.5 bars. I'm going to carry it down to -5 degrees C. So this is what? Water? Liquid water. Liquid H2O. H2O. Okay. So I'm going to freeze it. It's going to down to -5. So it's going to do what? It's going to have 1 bar. It's a solid now, right? Boom. It's going to go down to -5. I'm going to give it a half a bar. So initially I had what? 4.5 bars. Okay. Initially, that was what started the system. I ended up with 1.5 bars. Something happened. That energy left the system. It left the system. So I've got to show something with the arrow. The system had to give up, 3 bars of energy. So 3 bars of energy went to the surroundings when it froze. It started at 40 degrees C. It was water. It was liquid. It went to a solid. It had to give up 3 bars of energy. That's the purpose of the energy bar charts. EBDs, EBCs, whatever you want to call them. It gives us an opportunity to see what's going on with the energy flow. Is it flowing into the system? Is it flowing out of the system? It really helps you understand what's going on. Again, the key thing to remember, a solid is worth 1 bar, a liquid is worth 2 bars, and a gas is worth 4 bars. That's all you got to worry about. Then show me a temperature difference. You'll be good to go. But you got to think what's happening with the system. Okay, guys, this is Coach Scott with the review part 1, the energy bar diagrams. And if you get this, you'll have several questions. You'll get several points off this. Thank you, guys, and I'll see you later. Hullabaloo, connect.